Okay, good morning, everybody. So this talk is a summary of the work we have been doing in the Atlantic Salmon case study of the ECOKNOWS project. So a lot of people have been involved in this case study who are listed here. So this is the occasion for me to thank everybody. And in particular, maybe Atso Romakanimi, who led the case study. Well, this is the outline of my talk. First, I will give some context about Atlantic salmon stock assessments in the Baltic Sea and in the North Atlantic Ocean. And then I will try to explain briefly why we have proposed the hierarchical Bayesian modeling framework as a template for harmonizing the assessment approach in both the Baltic and the North Atlantic. And third, I have chosen to illustrate the approach by the progress we have made in the assessment models for the North Atlantic. And then I will conclude by a few research perspectives. Okay, so let's start maybe with this question. What is the most appropriate scale for Atlantic salmon stock assessments? And well, we had a lot of discussions about this issue during the project, and I guess there is no simple answer. So Atlantic salmon have a particular life cycle, and because of the importance of the riverine habitat for reproduction and the rearing of juveniles, and also because of the homing behavior, one may say that the river is the base scale for stock assessments. But however, one may also argue that it could be a good way to assess stock at a broader scale, the scale of stock complexes. Indeed, often the data are available on only a small proportion of rivers, something about maybe 25% in the North Atlantic. And there are also factors that are susceptible to impact populations at a broad scale. For instance, environmental factors on feeding areas, on marine feeding areas, and also marine fisheries, which are susceptible to harvest mixed stocks. In fact, there is a variety of scales of analysis and also a variety of assessment methods. And this variety is well illustrated in the approach which are used in the Baltic and the North Atlantic. So let me now give you a few details about the model which is used in the Baltic, but the model has already been fully described by Paulina yesterday. So in this model, the population dynamics in 15 salmon rivers, both in Sweden and Finland, is explicitly represented. This is an integrated life cycle model that explicitly includes the cohort dynamics. And both estimation and forecasts are done in a Bayesian framework that allows to assimilate various sources of information. We have surveys in monitored rivers and also informative priors on many key parameters. And ultimately, the model is produce some probabilistic forecasts of returns in each river under different fisheries scenarios. And the model is written in the Bugs language. The models that are used in the North Atlantic are totally different. And maybe the primary difference is the question of the scale, because the assessment models are working at the scale of three large, very large stock complexes, which are groups of population that are supposed to share some common influence of large-scale environmental conditions, and that are also impacted by marine fisheries that harvest on mixed stock, both at the Faroes, around the Faroes fisheries, and also around the western Greenland coast. So we have three big stock complexes: the North American one, the Northern European one, and the Southern European stock complex. And all stock complexes are subdivided between regions of country depending upon the place. The second difference is the type of the models. Those models are not life cycle models, but rather they are I would say, classical stock recruitment approaches. So briefly, the national data are first aggregated at the scale of each stock complexes, and those data are used to produce time series of egg depositions in each stock complex each year. This is the measure of the stock, and those data, the same data, are also used to produce an estimate of the abundance of post-molts at sea. That is called the pre-fishery abundance, because we consider this stage just before any fisheries at sea. And once those two time series are estimated, then it's possible to estimate the time series of the productivity parameter between eggs and recruits. And this time series is used then to forecast the returns based on different fishery scenarios. Those models have recently been reformulated in the Bayesian framework, but still they are not integrated life cycle models. And so, to summarize, we can see that the differences in the models are motivated both by differences in spatial scales, I mean the level of aggregation, and also by differences in terms of available data. However, both groups share some common objectives, for sure. Estimate the abundance, understand key drivers of the population dynamics. On the short term, both groups want to minimize risk, measured, for instance, at the probability that the egg deposition fall below spawning targets, and on the long term also to be able maybe to anticipate evolution of demographics and abundance. And both groups share common challenges. First, most of the biological bases of Atlantic salmon life cycle are common, for sure, between the Baltic and the North Atlantic. This is the same species we're talking about. Both groups are dealing with the context of metapopulation, with factors that impact population at different scales. Of course, population dynamics is a hidden process, and everybody has heterogeneous sources of data depending upon the scales. So this is why there is a need and also an interest to harmonize the modeling approaches. Okay, and in this project, so we have proposed to use the hierarchical Bayesian modeling framework to harmonize the modeling approach. So we have been talking a lot about this framework during this symposium. So very simple idea, but very important in my view. I think that most of the flexibility of this framework comes from the fact that the state process and the observation process can be modeled separately in this framework. And this provides a huge flexibility in the models. And when we are dealing with different stock units, and this is problems where we have, first, this framework allows to code, to model the common ecological knowledge for the different stock units in the equations for the population dynamics that define the states given the parameters, and also in the priors for the parameters. Second, the dependence among the stocks can be modeled through hierarchical structures on the parameters that promote exchange of information between parameters and then between stock units. And everything can be done while maintaining some specificity in the data assimilation scheme for each stock unit. And maybe this is a key. And so this is a nod to the famous French cycle race, you know, the French tour that will start in July, very soon. And I think it's quite a good summary of the progress we have been doing during the project. And in particular, regarding the North Atlantic models, we spent a lot of energy to climb the first mountain, I will say, that is for embedding the assessment model within a hierarchical Bayesian framework. And so this is what I would like to illustrate now by focusing on the models we have developed for Atlantic stock assessments for the southern European stock complex, so the one in the red box here. So most of this work is derived from the PhD thesis of Félix Massiot-Garnier that many of you know here. Okay, so in this complex, for each of the 8 regional groups of stocks that compose this complex, so we have 8 groups of stocks because, for instance, as you can see here, the Scotland is divided between Scotland West and Scotland East. So we are not talking about countries, we are talking about regions. Those are the scales at which the data are first aggregated. So for each of the 8 regional groups of stocks, we have developed a life cycle model that has a common structure for each group of stocks. But of course, the parameters in each regions are specific. Well, the model is an age and stage-based life cycle model that is built in a state-based modeling framework. So the population dynamics is a hidden process. And here you can see that we have 2 different life histories. And for instance, the fish in blue here that are fish that will mature after only 1 winter spent at sea, and that will return as once-a-winter fish. And those fish may be harvested at the Ferries fisheries here. And in green, we have the fish that mature after 2 winters spent at sea, and that have the potential to be harvested both at the Ferries and also at the Western Greenland fishery. And we are mostly interested in this model in estimated 2 key parameters, which are the marine survival of smolts during the first month at sea, which is a critical phase for the Atlantic salmon life cycle, and also the probability to mature after only 1 winter at sea. So I will go fast here. The model is written in Bayesian framework. We simulate time series, 43 years of data here. We have data for each different regional groups. And those data are supplemented also by some informative priors on different parameters. But I don't have the time to give a lot of details here. So, sorry. Okay, so those are the kind of results we have. Of course, the model allows to estimate the abundance of fish in the different life stages. And here I have drawn the abundance at the post-smolt stage for each of the different regions or country. And so we can see that the abundance is dominated by Ireland and Scotland, of course. But if we look at the abundance relative to the first year for each country, you can see that there is a consistent decreasing trend in the abundance. That could well maybe reflect common trends in some key population dynamic parameters. And so to capture these trends, in the second step, we have built a hierarchical model that encapsulates the dynamics of the 8 regional groups of stocks within a single model. And this model explicitly captures the covariance in the time series of the 2 key parameters I was talking about, the marine survival rate and the probability to mature as once-a-winter fish. So I don't have the time to detail the different structures we have compared to model the covariance. Maybe you can come back to this if we have time for the questions. So those are the kind of results we have for now. We are able to draw inferences on the time series for both here the marine survival and here the probability to mature. And I have drawn in black line and in gray line, with a gray shaded area here, the common trends that we can extract directly from the hierarchical model. That is the trends in those survival and probability to mature, which is shared by the different regions. And the results show that the covariance among regions is quite high. The common trend explains more than 50% of the total variance in time. And broadly speaking, a joint analysis of the different groups of stock in a single hierarchical model outperforms a model where the 8 regions are considered as independent. Outperforms in terms of quality of fit and also in terms of some forecasting performance criteria we have calculated by cross-validation tests, for instance. So I think, well, it's time to conclude. I will say that a lot of progress have been made during the project, and in particular, thanks to the progress we have made for the assessment model in the North Atlantic. No, we have a common methodological framework. This is the hierarchical Bayesian integrated life cycle model that is common for the Baltic and the North Atlantic. And in my view, this is maybe certainly the most important results we have. We have a common framework that should promote in the future exchange of information, of experience between the two groups. And of course, we have some research challenges, a lot. So what next? Maybe for the few words for the North Atlantic side, we would like to extend the approach to the 3 stock complexes, because we only have a model for the moment for one of the 3. And also we'd like to improve the connection with stock assessments at a national scale. And this is an important challenge, and I should say that some work has been engaged in this direction in Ireland by Jonathan and Guillaume in the project too. And also some challenges are common for the Baltic and the North Atlantic side. And here I have listed 3 of them, but there are so many. Maybe a few words about the first bullet here. Because we have this common methodological framework, it will be possible to build and to think about building common priors for the 2 sides. And also, I have to say that some work has been engaged in this direction, in particular for the X to small survival rates. So what happens in the freshwater phase? We have started during the project a meta-analysis of this for these parameters by using the data we have on many monitored rivers all over the world. And second bullet, which is of course an important issue here, we have to improve our understanding of the mechanisms that drive the trends that we have seen. For instance, we have to explore the trophic conditions hypothesis, and well, many research exists already in the Baltic and the North Atlantic side around this question. So we have to work together, I think, to improve and to go further into this. Well, I guess that's it. Thank you for your attention, and once again.